So again, let's go into our template here for our analysis. And let's see what we need. We just need the data for 0.61 millivolts. So let's just go back and grab that data. It's in here. And it's already selected. So I'm just going to select on the column at the top, and I'm going to say copy. I'm going to go back into our template here. And we're looking at the same thing. When I say same thing, we still have our same tab here. I'm just going to go ahead and paste that in. And I want to make sure that the data is going all the way down and that my calculations are going all the way down. So I'm just going to fill that, drag this down. Remember that the average here, I want that average to be the entire column for H. All right, so it changed the average a little bit there. The next one we'll need is the 1.81 millivolts. So I'll go back. And you'll see that the data is already selected. So I'm just going to copy that, go back to the template. And then just paste it. And again, you see that division by 0. We're going to have the same kind of phenomena taking place here. And let's just delete all of that information. And we'll see that our angular velocity is calculated. Let's make sure that we have the entire column of H selected there for the average velocity, the average angular velocity. If we go to interpolation, you'll see that we have our same sheet here. If we go to extrapolation, you'll see that we have our equation there. And then if you go to 1 millivolt, you won't see the, and let me just change this to a capital V. It is not a little v, it is truly a capital V. And so we have this. We need to go ahead and grab this data as well. So let's go back and get our 1 millivolt data set. So let's view our data. I do this on purpose. I just figured that it's going to eliminate errors. So I'm just going to copy this. Then I'm going to go back into the template again. And I'm going to paste the data into B, C, D, and E. We're going to, you see we still have a division by 0, so that means our data set is not going down very far. That means, I mean, we could have gone all the way around to the end of the video, and that's most likely what this stuff means. So I'm just going to delete this. Delete seems to work very well, and we have our average angular velocity here. Let's go ahead and change this to the entire column, H colon H, and we have 7.90. If we go into our percent difference here, you're going to see that we have something weird. Let me see what this is saying. We have this interpolation measurement percent difference. Okay, something is wrong with this percent difference. We want to check the percent difference for this 1 millivolt. All right, so at 1 millivolt, we're going to take this extrapolation equation, okay? And you'll see this extrapolation equation is just, let me move this down. Maybe I already have it. Nope. I'm going to take this extrapolation equation and put it into our percent difference. This is going to be what we're interpolating. Because and I say interpolating, but this is our measurement here. So I'm just going to say equals to, and it's, you know what, I'll do it on the other page. I'll go to extrapolation. I believe I must have thought that I'll have this one in here. So I'm just going to call this equals to, and then we have 8.037 times, now what we need is the voltage at 1. So we want to put 1 volt, and it's going to be, this represents 1 millivolt. And then minus 0.7905. So I'll just drop this. And that is the value, and I should give this appropriate. This is the predicted value from interpolation. So I'll just say, yeah. So let me just wrap that. So our predicted value for interpolation. Okay. And this is what we're going to put into our percent difference. All right, so the formula was just wrong here. And I want to say equals to, let's back this up. Go back here, go to predicted value for interpolation. And then our measurement is going to be what we actually measure for 1 millivolt. And that's here. It's 7.98. So now you'll see that our interpolation, or our prediction, and I'd even rather say prediction, it's our hypothesis, you know, all of that stuff. Is our prediction. And then you have your then you have your measurement, and you have your percent difference between them. It's approximately 10% between them. So if you go back to your extrapolation, that tells you how strong your graph is, or your methodology is. And you'll see that this equation will give you a nice prediction. But you always have to say, well, to within 10% error. Okay? That could be a plus or minus. And it just, right now, you might determine that it's just positive, or you might determine that it's just negative if you just go through everything. So that's the end of this. Make sure you submit all of this information to STEM.